All right, guys. What we're starting today is chapter 2. So, yes, we are going to be going at a decent pace because to stay on track for how they want this class to go and how we want this class to go, we need to finish chapter 3 before spring break. So finish it and test before spring break. Now, most of chapter 2 is going to be dealing a lot with graphs, intercepts, x and y intercepts, and stuff like this. Now, we will deal with circles, absolute values, quadratics, radicals, many different types of functions. But what we're doing today, 2-1, is going to be I think it's going to be very easy for y'all to do. As you've seen, the note sheet that y'all have is pretty short. There's not a whole lot to this. One of the first things that we're going to talk about is the Cartesian coordinates, or the coordinate plane. And the coordinate plane has 4 main quadrants. And we call them quadrants 1, 2, 3, and 4. And the quadrants all go counterclockwise. We start in the first quadrant, which is positive in both the x and y axis. So the x and y values in the first quadrant are both positive for both x and y. In the second quadrant, we have negative x and positive y. In the third quadrant, x and y are both negative. And in the fourth quadrant, we have positive x and negative y. And any point, xy pair, can be plotted on the coordinate plane, where the origin is at the point 0, 0. Y'all done this before. This isn't anything new. So, I mean, we could plot any point here. So we could say the point 3, 3 would be over here, or we could say negative 4, 4. X is always first, y is always second. Nothing new here. Plotting points. Now, distance between 2 points is given by this equation. D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And given any 2 points, we plug the x values in here, y values in here, and simplify. Now, the order of the x and y values really doesn't make a difference for this here, mainly because of the squaring them. Because if we flip them, all we're doing is changing the sign from positive to negative or negative to positive. Because if we said the 2 x values were negative 5 and 4, well, doing negative 5 minus 4 is going to be negative 9. If we did 4 minus negative 5, well, the negative and negative would make a plus, giving us 9. So taking 2 numbers and subtracting them in either order really just changes the sign. But if we're squaring it, well, negative 9 squared is 81. 9 squared is 81. So because of the square, it takes care of the sign change. So the order doesn't matter. All we need to make sure is that the x's go with the x, go together, and the y's go together. So if we're looking for the distance between these 2 points, all we've got to use is the distance formula. x2 minus x1 squared plus y2 minus y1 squared. And looking at these 2 points, our 2 x values are negative 5 and 7. So we can say 7 minus negative 5, plus our 2 y values are 1 and negative 3. Now, I set them up this way here, especially if I'm doing this by hand or having to calculate this distance formula by hand. I like putting the negative second. That's mainly because a negative and a negative make a positive. So we're really looking at just 7 plus 5 and 1 plus 3. 7 plus 5 squared is 12 squared plus 4 squared. 12 squared is 144. 4 squared is 16. And 144 plus 16 is 160. Questions on this here? Now, realistically, since we do have a calculator, we could have just plugged in this equation here and just let the calculator do it for us, even with the negative negatives. Now, it wants us to give the exact distance and an approximation to 2 decimal places. So the exact distance is the square root of 160. Or we can plug it in a calculator, say second square root 160, and get 4 squared of 10. So it does simplify. So we can say the distance is equal to 4 squared of 10. And that is the exact distance. Now, if we want to approximate, it means we want to turn it into a decimal, to 2 decimal places. So we have 12.649. Since the 9 is closer to the next 10 spot, we're going to round it from 0.64 to 0.65. And that's it. Any questions on any of this here? We good with this? Hopefully. Midpoint. The midpoint of a line segment with endpoints x1 and y1 and x2, y2 is given by this formula here. We add the x values together and divide by 2. We add the y values together and divide by 2. And we get the midpoint. So if I wanted to find the midpoint of the line segment with the given endpoints, well, midpoint is x2 plus x1 divided by 2, comma, y2 plus y1 divided by 2. And for us here, the two x values are 4.2 plus negative 2.8 over 2. And the y values are negative 4 plus 3 over 2. And with this here, order doesn't matter, because with addition, we can add any two things in any order and get the same number. (4.2) plus negative 2.8 is 1.4. Negative 4 plus 3 is negative 1. And lastly, we can simplify these. Half of 1.4 is 0.7, comma, negative 0.5. If we wanted to leave it as fractions, it would have been 7/10, comma, negative 1/2. Questions on midpoint? We feel good with distance and midpoint. Determining an x and y intersect of an equation. X and y intercepts. It's just where it crosses the x and y axis. If it crosses the x-axis, so on a Cartesian coordinate, so the x-intercepts are going to cross the x-axis. Well, what is the value of y at the x-axis? Well, the value of y is what? 0, yes? So if we're solving for an x-intercept, we want to solve it for where y is 0. If we're looking for an x-intercept, y-intercept, where it crosses the y-axis, what is the value of x? 0. So if we're looking for a y-intercept, we're looking for where x is 0. Or if we're looking for an x-intercept, we're looking for where y is 0. And that's really all we need to do to find them. Now, in some cases, it's a little bit easier to find them than others. But in any equation, all we've got to do is substitute 0 in for one or the other. So for part A of this here, we want to find the x-intercept. And the x-intercept is where it crosses the x-axis, where y is 0. So all we need to do is replace y with 0 and solve. Now for this here, we do need to get the absolute value by itself. So we'd add 1 to both sides, telling us that the absolute value of x is equal to positive 1. Well, we know that the value of x is either going to be 1 or x is going to be negative 1, because the absolute value of 1 is still 1, and the absolute value of negative 1 is 1. So the x-intercepts are 1 and negative 1. Now for the homework, it's just going to take 1 comma negative 1 as the x-intercepts. That's all you need to put. Now for the most part, realistically, the x-intercept is a coordinate, x comma y value. Because we think of the x-intercepts as a point, not as a given value, technically speaking. But the homework, especially online, you're just going to put 1 comma negative 1, and that's it. That's all they want. Now the y-intercept, well, that is where the value of x is 0. Well, the absolute value of 0 is 0. And that's it. So we have 1 y-intercept and we have 2 x-intercepts. That is not uncommon, especially if it is a function. We can have more than 1 x-intercept with it being a function. We cannot have more than 1 y-intercept and it still be a function. Because it's been a while, but if you remember back to Algebra 1 when we talked about functions, defining a function, for it to be a function, it had to pass the vertical line test. We couldn't draw a vertical line and it intercept the function in more than one place. Yes? Well, the y-axis is a vertical line. So if it crosses the y-axis in more than one place, therefore it's not a function. However, the x-axis can be crossed more than once. We can have multiple x-intercepts. Now, for the graphing calculator, math. If we go over 1 to numbers, so if we hit math, go over 1 to num on top, the first option, ABS, is not anti-braking system. It's absolute values. That's our absolute value. So we can hit enter, and it'll pull up the absolute value for us. And what we can do with this here is say x minus 1 graph. Gave us a graph. We can go second table. So x-intercepts, we're looking for where y is 0. So we have negative 1 and 1. For y-intercepts, we're looking for where y or x is 0. So the y value is negative 1. They gave it to us. Questions on this here? Find the equation. So given the equation y equals x squared minus 4, find the x-intercepts and y-intercepts. So one thing we can do is say x squared minus 4 graph. Sure. Yep. So how many x-intercepts do we have? 2. How many y-intercepts do we have? 1. So the x-intercepts, I can go second table. One of them is at -2. The other is at 2. And for the y-intercept, we're looking for what value of x? 0. And when x is 0, y is -4. And that's it. Questions on this here? Now, this makes sense, especially with the last two, because our general function for quadratics, the parent function of quadratics is this here. Now, the reason I bring this up, and we'll deal more with this later, is I'm not going to focus so much on A at this point, but H and K. H is left and right. K is up and down. Now, we didn't have a left and right movement here. The reason I know that is because left and right's inside parentheses, or absolute values. It's stuck inside there. And it's always opposite of what we think. So if we had inside the parentheses x minus 2, it seems like it would move 2 units to the left. It's actually moving 2 units to the right. Up and down is exactly what we think. So if it's plus 4, it's going to move up 4. If it's minus 4, it's going to move down 4. And the vertex of any quadratic, vertex, the highest or lowest point, always starts at 0, 0. Now, if we look at this one here, x squared minus 4, it's telling us it's moving where? Down 4 units, yes? So, if it's the original xy is at 0, 0, we move it down 4. We're now at 0, -4, which is our y-intercept. If we look at the one before, absolute value of x minus 1, well, the origin for the absolute value, because it is a v shape, moved it down 1, making it 0, -1. And our y-intercept was what? 0, -1. And we'll be looking at these movements and transformations of functions as we go along. But that's mainly it for this here. Any question on this here? Now, one of the things I will say, if we do have, I'll write this in, rational functions, if we're looking for zeros, if we're looking for x-intercepts, because we're trying to see when this function here becomes 0, yes? Because we're trying to look for the x-intercepts, we need y to be 0. How can I make a function, or not a function specifically, but a fraction be 0? What's the only way we can have a fraction be 0? Is if the numerator is 0, yes? Doesn't really matter what the denominator does. This has to be 0. So if I wanted to find the x-intercept for it, I don't have to deal with the whole function. I'm just really focused on this. We could add 7. Divide by 6, telling us x is 7/6. Because the other way to go about doing this, to solve, is multiplying both sides by 4x squared plus 5. Because if I do that, these would cancel. And what I do to one side, I have to do to the other, which would leave us with 6x minus 7. Well, 4x squared plus 5 times 0 is, surprise, surprise, 0. So we'd end up doing the same thing, still getting that x is 7/6. And going the other way, finding the y-intercepts, well, that's just plugging in 0 for x. 6 times 0 minus 7 over 4 times 0 squared plus 5. Well, that's 0, that's 0. We get negative 7/5. Questions on this here? Question on any of this so far? Now, x-intercepts and y-intercepts for everything you've covered so far, especially in Algebra 1 and Algebra 2, there's always been an x and y-intercept. We've always seen functions that cross both, or at least one. And that's not always true. It doesn't always have to cross one or the other. Say the square root of x. I'll do this. Right, 2, and up 2. This function here will not cross the x or y axis. It just won't. It won't cross either. X minus 2 plus 2. Because if we set it equal to 0, well, we would subtract 2 from both sides. Well, we know with radicals, there's no way to take a square root of something and get a negative number. So there is no x-intercept. There's no value of x that will give me a y value of 0. Okay, let's do it the other way. So if I plug in 0 for x, 0 minus 2 is negative 2. Can we take the square root of a negative number? No, it doesn't cross either axis. So there are some cases where it doesn't cross either. Some that it can cross more than one. Because if we have circles, it'll cross the x and intercepts possibly more than once. Doesn't have to. It could. But that's it. Let me give you all the rest of the time to work on the assignment.